Welcome to my channel once again. This is Shatari. In our previous lesson, we treated some reaction involving organic compounds, e.g. combustion reaction. We treated addition reaction and so on. In today's topic, we're talking about how to name these organic compounds from simple one to more complex ones. So there are some arbitrary rules guiding this naming of organic compounds. One of them, if a given compound, for instance, is given to us, it's given the structural formula of a given compound is given to us this way. For instance, we say this is an organic compound that involve alkane family. How did we know the alkane family? So there are the rules for us to understand how to name organic compound. One of them, we must identify the functional group. We must know the functional group of such compound so that we know the parent name of such organic compound. So we must understand, we must identify the substituent. We must know the substituent by identifying the longest continuous chain. So the third one, we must know the longest continuous chain. So in case of an alkane, when it involves alkane family, we said we must give preference with the numbering. We must give preference to the substituent. For instance, say the substituent is giving preference in terms of numbering. So the substituent is giving preference in terms of numbering. So that is to say, in this aspect now, let's use this analogy to explain this structural formula. We said one of them, we must identify the functional group. So if you check this compound, it contains a single bond. And from our previous lesson, any organic compound that contains a single bond is from a family known as an alkane family. So we must identify the substituent as well. So from there, we must know the longest continuous chain before we can know the substituent that is involved in this organic compound. So for this now, if we should number from 1, 2, 3, 4. We should number from here 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. So in this aspect, we can take any of the brand, but we must give preference to this, any of the substituent we are taking. If, for instance, we are numbering from here 1, 2, 3, 4. So one of the rules is that we must identify the longest continuous chain. Like this chain now, is the longest continuous chain. It contains 4 carbon. So if I should number here, if I should use this 1, 2, 3, 4, it also contains 4 carbon atoms. So if you're going to number from here 1, 2, 3, 4. So if you are using this numbering, automatically this becomes a substituent. So if you are using this numbering, this becomes a substituent. So by so doing, if peradventure we are numbering from here, let's use from here 1, 2, 3, 4. Or we are numbering from here 1, 2, 3, 4 as well. In this aspect, here, if you are using this numbering here, that means the highest, this substituent you are giving is 3. In this aspect, if you are numbering from here, you are numbering from 1, 2, 3, 4. This numbering, we are giving this substituent the lowest number to be 2. So in this aspect, it is preferable giving this substituent the simplest, the lowest number. I mean, it must be giving the lowest number. That is to say, we are going to make use of this numbering. Since they have the same carbon atom at each end, we are going to make use of this straight carbon. with the number 1, 2, 3, and 4. So that we can take this place as a substituent. So we are giving this lowest number, this 2 to this substituent. So in so doing, we have different rules. As we go with different examples, I will bring in out different rules on how to go about this whole issue. So in this now, if we should number from here 1, 2, 3, 4, we should number from here 1, 2, 3, 4. So the number we give using from the downside is 3. We are giving this substituent 3. We are using from up. We are giving this substituent 2. So we are going for this numbering that gave this substituent the lowest number. That is to say, we are able to identify the functional group. They said the other one we must understand, and a substituent. So a substituent is given to us as CH3. We said CH3 when an alkane family such as methane, CH4, when it loses an electron, it gives birth to a methyl group known as methyl. So we have CH3. This is known as methyl group. So by so doing, we already identified the substituent. We have known the functional group. So we have known the longest continuous chain contains 4 carbon. So a 4-carbon alkane is known as butane. So by so doing, we already know the major aspect of this organic compound. By so we'll continue to name now. So in this now, we said if you are writing a number and a word, so we must indicate them, differentiate them by writing a stroke between them. That is to say, we have this. If you are writing two figures together, we'll say comma. We write comma to separate each of them so that we'll not make mistake in doing all this. So by so doing, if you are able to name, let's name this simple compound. In here, we must give preference to this substituent. Is giving us at carbon 2. We say we have 2-methyl. 2-methyl at carbon 2. We said at carbon 2 we have 2-methyl. So what is the parent name? Since the parent name is it has a single bond, and if the family is alkane, and the four carbon atom is known as butane, it is known as butane. It's known as butane. So this compound is known as 2-methyl butane. So by so doing, if paraventure with the essence of this IUPAC nomenclature, we should be able to use this IUPAC nomenclature to get the structural formula of this compound. That is the essence of having this IUPAC nomenclature. That is to say, for us to have this structural formula of this compound, we said the family name is butane, and every butane contains say 4 carbon. So we can number from here. Let's number from here to be 1, 2, 3, 4. It means that at carbon 4 we have a methyl group. At carbon 4 we have a methyl group. So with the help of this IUPAC nomenclature, we are able to obtain the structural formula. That is the essence of this naming of organic compounds, so that we can be able to identify each of the organic compounds. In this now, I can say this is an isomer of propane, for instance, because when we say they have the same molecular formula but different structural formula. For instance, now if I want to write the molecular formula of this compound, I can have here we have CH3, the molecular formula CH3. At this we have we have one of the hydrogen here. We have the CH3. We have CH2, we have CH3. So in this now, let's have how many hydrogen is here? We have 3, 4, 7, 9, 12. That is 5 carbon and H12. H12. So what is the molecular formula for peptane? We can say is C5H12. Or for butane, we said the first member for alkane is CH4. When we have a homologous series, we have CH2, H6, we have C3, H8, we have C4, H10, we have C, H5, H12. So we can say this compound is an isomer. This compound is an isomer of peptane. So with this now, we should be able to know how these structures are arranged. So our next example, we're going to talk more about the different rules. So if peradventure we have a substituent that contain an halogen family like chlorine, it contains chlorine. Halogen family like bromine, it contains fluorine and iodine. So in naming of organic compound, this halogen family becomes we call them a different name. When we get to chlorine, when chlorine is attached to an organic compound, it automatically becomes what is known as chloro. So bromine becomes bromo. We said fluorine become fluoro. So in this it become iodo. So if we should have more than one substituent of a halogen family, and we are about to name the organic compound, we can use alphabetical order to arrange these substituents on the compound. That is to say, if we should have bromo and chloro in a compound, bromo will come first. We are going to name each of the substituents alphabetically. That means bromo will come first. And if you are naming an alkane, bromo, the numbering will be given, the lowest number must be given to the one that will come first. So in this now, we're going to have a different example. We said for us to name an organic compound, one of them, we must identify the functional group. We must know the substituent. We must know the longest continuous chain. We must know the substituent is given the preference in terms of numbering. That is in the case of alkane. In the case of alkane. So let's make use of a different. I'm going to use another example. We have C. We have chloro. Here we have bromo. Let's say we have Br. Here we have methyl. We have methyl group. So if we should have a compound like this, how can we name this organic compound? So in this now, we are going to focus more about this alkane family before we move to the next aliphatic hydrocarbons. So in this now, we're going to talk about 1, 2, 3, 4, 5. So in this now, let's number from here 1, 2, 3, 4, 5. They have both the longest continuous chain contains 5 carbon. So in this now, what is the functional group here first? The functional group is a single bond that is an alkane family. It's an alkane family. So in this now, we will know the longest continuous chain 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. So they have 5-member ring, 5-member alkane. 5-member alkane is known as pentane. So the parent name must end in pentane. So in this now, we're going to talk about the two major ones. So yeah, if we should say, let's give preference to the substituent now. So if we should number from here 1, 2, 3, 4, 5. Here at carbon 2, we have bromo. At carbon 3, we have chloro. At carbon 4, we have methyl group. We have methyl group. So what happened here is that if you should see this aspect, you can see bromo, chloro, methyl, and carbon. Okay, let's number from here. 1, 2, 3, 4, 5. You can see now at carbon 2, we have methyl. We have methyl. At carbon 3, we have chloro family. So at carbon 4, we have bromo. So for preference, since bromo is coming first, it is preferably we give the bromo the lowest numbering. So we're going to take this numbering at the up of this. So here we're going to name it accordingly, alphabetically. Since we have how many substituents? We have the chloro, we have bromo, we have methyl group. So in this now, we can name this organic compound easily. We said at carbon 2, we have bromo. As I've said, we have bromo. At carbon 3, we have chloro. At carbon 4, we have 4-methyl. So what is the parent name? The parent name is known as pentane. 2 bromo, 2 chloro, 4-methyl, pentane. So if peradventure we are having 2 substituents at the same carbon, so we are going to make reference to that. So if peradventure we have, for instance, let's use a very common example as well. Okay, let's wipe this and have a more proper example to illustrate other examples. So let's have we have chloro. Let's say we have chloro. We have H. Let's have H. Move from simple to complex. Let's use a simple one here. So if you should check this, it contains two substituents, two same substituents known as chloro. So when we have more than one substituent, we can use a di to represent 2. We have tri to represent 2. So in this aspect, it's a very straight chain. So we can use 1, 2, 3, 4. In this now, we must give the lowest numbering to the carbon as bearing the chloro. So in this now, we can say here, we can number from here 1, 2, 3, 4. Here we can say, what can we do here? We'll say at carbon 2, we have 2. We can say dichloro. 2-dichloro butane. So if you should check this naming is a bit confusing, because at carbon you said 2-dichloro. So in this aspect, if I'm trying to write using this IUPAC naming to write the structural formula, we said we have 2, 4 carbon. Yeah, we said at carbon, I can say carbon 2 is chloro. There's a chloro, but this is not actually telling the position of this chloro, these 2 chloro we are talking about. So in this aspect, we can make reference that this we can make a more simple naming by adding some value to this naming. We can actually say that at carbon 2 we have 2 chloro. I can say at carbon 2 we say 2. That means at carbon 2 we have the 2 dichloro in it. We say 2 dichloro. It means that At carbon 2, we have the 2-chloro attached to it. So the parent name can I equally come in 1, 2, 3, 4 as butane. So this will give me a better idea if I'm writing the structural formula. That is to say, at 2, I can number from here 1, 2, 3, 4. At carbon 2, we have the 2-chloro that is attached to the carbon. So this will give us a better idea on naming organic compounds. So in this now, if substituents are more than same substituent are more than 1, we use a die, we use a try to indicate their position and their numbers on the compound. So in this aspect, you're going to move directly to different examples. What if we have a situation like this? Let's have this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let's use So what can we do here? If you check this, we have a different way of naming. Let's say we must identify the longest continuous chain. So I made this carbon to be to this extent so that we can actually capitalize on our understanding about this naming of organic compound. If you check here, 1, 2, 3, 4, 5, 6, 7. You check here, 1, 2, 3, 4, 5, 6, 7. So yeah, the chain still continue. 1, 2, 3, 4, 5, 6, 7, 8, 9. That is 9. You check here, 1, 2, 3, 4, 5, 6, 7. So the longest continuous chain contains 9 carbon. Say 1, 2, 3, 4, 5, 6, 7, 8, 9. So it contains 9 carbon. We are going to talk about that is non-name because it's a single bond. Or if you check the compound, it contains only single bond attached to carbon. So in this now, we said it has 9 carbon. The longest continuous chain contains 9 carbon. So in so doing, we said we must give the substituent the lowest numbering. That is to say, if I'm numbering for here 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7. So here now, if I'm numbering here 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we can start the numbering from any end because they have the same value is given to this carbon that is having this substituent. So by so doing, can have same numbering because this carbon that is here 8, 9. So we can have the same numbering. So here it's an ethyl family. So we said ethane. We said C2H6. When it loses an electron, it gives it to C2H5. This is automatically become ethyl. So in this aspect, what can we do? We can say at carbon 5. This is a straightforward naming 5 ethyl. 5 ethyl nonene. Very simple. So I just give this a long carbon atom so that you know the longest continuous chain we are trying to explain. So we have spent a lot of time on this alkane family. Let's move to unsaturated hydrocarbon. So in unsaturated hydrocarbons, we have different methods here the preference is given to the double bond or the triple bond. Lowest numbering must be given. Lowest numbering must be given to the carbon having this double or triple bond. For instance, now let's have so in this now, irrespective of the substituent in alkane family, we said most of the time the substituent is giving the lowest possible number. So in this presence now, in this alkane family, more preference must be given to this functional group. This carbon that is having the functional group automatically. That is, the lowest numbering must be given to the carbon bearing the functional group. So this functional group, we said two double bond is found. It's an alkene family. An alkene family is present. An alkene family is present, so the lowest number must be given to the carbon bearing this functional group. And make sure that this, so we have another one here, 5. So the longest continuous chain here must be written as 5 here. So it will not end here, because we have another carbon that is here. So the parent name, 5 carbon atom, is known as pentene. It becomes pentene. Now become pentene because this double bond is here. So more preference, and if you are naming this unsaturated hydrocarbon, you must tell us the carbon that is having this functional group, that is bearing this functional group. That is to say, you must signify automatically this carbon that is bearing this functional group. Though a preference is given to it with the lowest number. So now we're going to talk about at carbon 3. We said at carbon 3 we have a chloro. We have chloro. So in this now we can say we can start with that. We said chloro. You must make sure your parent name is there. So what is the pentene? You can say pent. So pent. At carbon 1 we have the what? The double bond, pent 1N. Or it can be written as chloro 2 pentene. 2 pentene. Oh, 1 pentene, I mean 1 pentene. That is to say, well, let's use this now. We said it's a pentene. We said at carbon 1 we have a pentene. 1, 2, 3, 4, 5. So we said at carbon 3, automatically this carbon bears. At carbon 3 we have the what? The chloro. So this will help us to have a proper functioning group. So in unsaturated hydrocarbons, what determines the numbering is the position of this double bond or the triple bond. So if peradventure I'm having something like this, triple bond here, let's use this to illustrate this as well. We can actually name this into be 3 as well, 3-chloro, pent, 3-chloro, pent, pent 1 YNE, because the alkene family is giving us as this. So we change the YNE in when we have the ANE, we change to YNE. So we are going to have something like this. Or we have 3-chloro 1 petine. So with this now, it's going to give us a better idea on how all these are arranged. So a proper understanding, let's use a different example as well. So let's have bromo here. Okay, it's okay. It's okay. Let's have this. So if you are writing the structural formula of organic compound, you must ensure that each of these carbon you are assigning hydrogen to must be bonded tetrahedrally. They should not have more than 4 hydrogen attached to it. If you check this now, we have 1, 2, 3, 4. So when it comes to double bond, you notice that 1, 2, 3, 4, so that you will not make mistake in writing the structural formula. Here we have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So this structural formula is well arranged. So when you have something like this, it's also known. Yeah, this is hydrogen, hydrogen, hydrogen. So in this now, we can let's spread this one out. So in this now, we'll now identify the longest continuous chain. So 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. So the functional group is double bond. It ends with ENA. It must end with it ENA. We have 6 carbon atoms. 6 carbon atom is known as what? Azene. Azene. So we have azene. So we in this now already know the parent's name. We must know the substituent that are attached. So here we have a methyl group. We have a methyl group. A methyl group. We have a methyl group. Here we have chloro. We have chloro here. We have the bromo. We have the bromo group. So what do we have here? We said methyl group, chloro group, bromo group. So we said we must give the preference, the lowest numbering to this carbon that is having this functional group. 1, 2, 1, 2, 3, 4. So invariably, we are going to number from here 1, 2, 3, 4, 5, 6, 6. So what can we do here? We said we have the methyl group, we have the chloro, we have the bromo. So the bromo will come first, followed by chloro alphabetically. We are going to number this substituent and alphabetically. If there are more than one substituent, we use alphabetically alphabet to arrange this thing so that it will be very, very okay. So in this now, we say bromo will come first. Bromo will come first. We can say we have 4 bromo. So at carbon, what follows in? Chloro. Chloro will follow. We have chloro. We have chloro here. We have trichloro. Trichloro. So what is next? We have 4-methyl. So at carbon 2, the functional group must show. We have S2N. Or we have 4 bromo, trichloro, 4-methyl, 2-azine. So in this now is very, very simple. By so doing, we can use this IUPAC nomenclature to write the structural formula of this organic compound. So if peradventure we have double bond here, what will change is the parent name will change to YN. So Y here we're going to have YNE. So it's very simple to arrange this compound in a different form. So this will be the end of this class. Please do well. This is a form of revision for my students. I know you have gone through this this naming of organic compounds in your various classes, and this will be as a form of summarized way of naming organic compound. As you watch this video, please do well to subscribe to this channel so that we can continue the good work we have started. And those of you that are starting JAMB this week, I wish you the best of luck. And for now, there will be a question on my page, a revision question that will help you to prepare towards your exam. Thank you for watching. And in our more video, we'll be talking about naming of organic compound with multiple functional group, so that the hierarchy of this functional group will play an important role for any organic compound to have the parent name. So the higher the functional group will play an important role in choosing or having access to the parent name. Thank you for watching. This is Teacher Atari once again. Thank you.